Good afternoon and happy third day of the Renewable Energy Summit. I hope you've had great sessions and conversations this week. And welcome to the Emerging Technologies 101 session. The full name of this session is Emerging Technologies 101, Reshaping the Energy Landscape. Kudos to Renew Wisconsin for incorporating these 101 sessions into the summit. There's always such a wonderful cross-section of people at this annual event, and many work in the renewable energy or related space, and many don't. So the basic idea for this 101, as you might imagine, is to create an information sharing space for folks who have expertise in other areas and aren't necessarily in energy discussion on an everyday basis. Today, I'm going to frame this emerging tech discussion primarily as beneficial electrification. And what I mean by that is, for a few years now, there has been a lot of buzz about beneficial electrification. And while it's useful to understand what that means discretely, it's probably even more useful to contextualize it and take stock of some of the major areas of interplay that are making electrification such a hot topic. On that note, I think the mosaic theme of this year's summit is particularly fitting because, just really points to the fact that to meet our clean energy and climate goals, several different things or factors intersect and are often greater than the sum of their parts. A few housekeeping items for the session today. We've got about 45 minutes together, and please use the chat box to engage with other summit attendees and use the Q&A box that will be moderated, but we'll plan to take questions at the end for the most part. The summit, of course, would not be possible without sponsors. So thank you to the generous sponsors who are supporting clean energy and the summit in particular. I'm Robin Lisowski. I'm Director of Service Solutions at Slipstream. Slipstream is a 501c3 nonprofit. So we've got the mission of accelerating climate solutions for everyone. And to do that, we create, test, deliver, and scale the next generation of solutions that can move us further and faster in a clean energy economy. I'm hoping we can interact a little bit, particularly day 3 in on a virtual seminar when everyone's been doing it for several months already. So I put together a few simple polling questions using Mentee meters. So if you could use the mobile device that you're using to attend this session, or a phone or other mobile device, and please go to a browser and enter www.mentee.com. And when that window opens, enter the code 727831. This is just basically to take a check-in and who's here, to see who's here. If we had any experts that snuck in. Great. Well, this is slowing down. We've got a really good cross section, maybe more clean energy industry folks than I would have expected in a 101, but we're happy to have everybody. Welcome. Oh. Okay, we've recovered there a bit. So certainly by the third day of the conference, you've probably seen several generation, consumption, emission statistics, but I always think it's helpful to ground a conversation like this in some numbers about current conditions. So I have several slides that I'll go through quickly, just really in that spirit. This graph shows global carbon dioxide emissions in million metric tons, rising from 1850 and projected through 2050. And for Wisconsin's part in that, these are how this is kind of an economy-wide display. It shows how the various economic sectors contribute to the state's emissions inventory. You can see the black arrow pointing to the fact that electricity accounts for the largest portion of overall emissions in our state. These data are from 2017, so we might expect the numbers to have changed some, but patterns holding. I'm hoping, thinking about that electricity and what makes it up, I'm hoping you still have your browser open, and we'll do another poll, kind of a quiz this time. If you could, again, go to that Mentee site, and if it's disappeared, re-enter 727831 as the code and answer the question that you see there, which is your estimate of the portion of electricity generation by type. Right, this is leveling off. Majority of our group is saying it's 11%. I've got 6 highlighted here for net generation, and we'll show that. Pardon the technical difficulty as I try to back out of.
Yeah, Robin, if you go ahead and click the PowerPoint icon in your control panel at the bottom of your screen, you should be able to go back to your PowerPoint.
There we go. This pie chart shows the Wisconsin net electricity generation. You see the 6 a little bit obscured in the teal at the top. That's for non-hydro renewables, and then if you add hydro to it, it accounts for 10%, which might have been what some folks were thinking when they populated that Mentee. The good news is that even though that's only 6 or 10%, that the carbon intensity of electricity is reduced over time, 29% since 2005, and it will certainly continue to do so with the addition of cleaner generation. We see here in Wisconsin that residential buildings account for about 9% and commercial buildings account for about 6% of the state's overall carbon dioxide emissions, specifically from energy. Those are slightly higher percentages than we see nationally. Shifting from emissions lens to energy more purely, this chart shows Wisconsin's energy consumption by end use sector. We've got industrial at the highest level there, but in fairly even proportionality. And then in buildings, residentially, we see when we look at end uses that space heating accounts for more than 50% of home energy use, and water heating close to 20%. Space heating also accounts for nearly 40% of commercial consumption when we're looking at end uses. Using national data and switching the lens back to emissions, again, we see that light duty vehicles are the #1 source, that first gray arrow there, and that residential space heating is the #3 source of energy related emissions by end use. So that really brings us, and all by way of setup, that really brings us to the value proposition of electrification, that we call sometimes beneficial or strategic or efficient. Basically, to take advantage of the cleaner generation, we must electrify end uses that have traditionally been powered by fossil fuels in order to reduce greenhouse gas emissions. Of course, not all electrification is necessarily beneficial. And a few years ago, the Regulatory Assistance Project put forth a great and simple set of helpful criteria, basically saying that to be beneficial, electrification must save money for consumers in the long run, it must reduce negative environmental impacts, and it must enable better grid management. And you'll see that I've added equity there too, and that's certainly an important fourth criterion when we're thinking about how we go about electrifying these end uses to ensure that it's a level playing field. So having walked through all of that kind of setup and emissions and energy consumption pie charts, it makes it pretty clear that it's important to address the building and transportation sectors and specific end uses within those sectors as we focus our electrification attention. So with that, I'm going to do a quick overview of 4 end uses, certainly not all that we could talk about or that are related here, and related technologies that are emerging in light of the benefits of electrification. And those are vehicles, space heating, water heating, and cooking. But before I do that, it's important to name that we have relatively few opportunities to electrify these end uses. Space heating equipment will probably only be replaced 2 to 3 times between 2015 and 2050. Water heating equipment might only be replaced 3 to 4 times in that same time span. Each furnace, water heater, car not electrified the next time it is replaced is a lost opportunity that effectively locks in fossil fuels for many more years before there's another chance to electrify. So overview of electric vehicles. Light duty vehicles are the single, as we saw in an earlier chart, are the single largest end use source of energy emissions in the United States, and accelerating vehicle electrification and adoption is a critical action to meet our clean energy and climate goals. An electric vehicle, this very basics, is one that at least partially runs on electricity, unlike conventional vehicles that use gasoline or maybe diesel. Electric cars and eventually trucks use an electric motor powered by electricity from batteries or a fuel cell. EVs are cleaner than even the most efficient conventional vehicles. Of course, how clean that is depends on the type of vehicle and the electricity that is serving it. But it's kind of helpful to think in average terms, in that when a battery electric EV is powered by pretty clean electricity, greenhouse gas emissions are comparable to like an internal combustion engine car getting over 100 miles per gallon. When charged exclusively with renewable energy like solar or wind, charging and operating an EV can be nearly emissions free. Though electric cars can be more expensive to purchase than their conventional counterparts, battery prices are certainly coming down, and price point option and diversity are increasing. Higher upfront costs can also be reduced through federal or state incentives, and operating costs are lower. The cost to refuel an electric car can be just a fraction of what gasoline would be. There are several variables to consider again, but when switching to an electric car, customers can enjoy operating savings of approximately $700 to $1,000 a year. I've got a snip on this slide that shows a Department of Energy tool on the Alternative Fuels Data Center site. I won't go into the tool here, but when consumers are thinking about comparing costs and emissions, this can be a useful tool to experiment with. In addition to those costs and emissions, certainly you keep in mind that the benefits of driving electric include that, that vehicle being really quiet. They're fun to drive. I have one. I have a Leaf. It's a great vehicle to drive. And then there's a convenience factor. We're sitting in January in Wisconsin, and when you have an electric car, you can plug it in your garage. You don't need to stop at a gas station. In terms of the status of EVs in Wisconsin, as of there are a handful of statistics here that kind of display the state of play for adoption. I'll highlight that in 2019, EVs were about 0.8%, even a hair less of market share, and there were fewer than 6,000 vehicles EVs registered in the state. You might notice at the top of this that the majority of sales for EVs that are registered in Wisconsin are actually purchased out of state. Tesla is what's contributing to that primarily. So on to space heating. Residential space heating also commands our electrification attention, right? It's the third largest end-use source of CO2 emissions in the US after just those two categories of transportation. And air source heat pumps are a key building electrification strategy alongside EVs. They've become a poster child of their own for the beneficial electrification discussion. Their equipment is highly efficient. They make 2 to 4 times more heat than electricity, and they're almost magical in the sense that they move heat instead of make heat. They extract exterior heat to warm a home when it's cold, and reverse that direction like a typical air conditioner would, and then transfer indoor heat outdoors to make it cool in the summer for you. The technology innovation has been notable in recent years, and it makes the heat delivery sufficient in even some of the coldest days in the upper Midwest. Maybe not all. That's still advancing. But by way of some temperature example, inverter-driven technologies, which you might hear called cold climate equipment, can keep homes comfortable to like -15 degrees when it's ductless systems, or 5 degrees when it's a ducted application. The ductless systems are delivering more efficiency. Certainly, there are several benefits to consumers from air source heat pumps, and that electrification avenue can reduce price exposure to fuel price variability, like we've seen in propane. Provides comfort, health, and safety in the home. Safety, primarily probably demonstrated by the removal of combustion. And can add cooling for, the equipment does both. It heats and it cools. So for folks who don't have an air conditioner yet, it's a 2-in-1 piece of equipment. Certainly through this electrification, it reduces emissions. There are many cost-effective applications, but the incumbent fuel certainly matters. With natural gas prices low, it's difficult to compete with in a cost-effectiveness sense, but displacing other kinds of fuel can make an air source heat pump the most cost-effective option. Federal and state tax credits or other incentives can help the cost effectiveness matter in the consumer's eyes. There was a $300 federal tax credit that expired at the end of 2020. And I'm not aware, I don't know if anyone else is, whether that's going to be renewed. To my knowledge, it has not been. Focus on Energy, our statewide energy efficiency and renewables program, currently offers air source heat pump incentives, and it's supported with TRM, the technical resource manual calculations. There were 36 projects, 36 air source heat pump installations in 2019, according to the evaluation. The pink box at the right just shows that the breakout of how we heat in Wisconsin, primarily natural gas, which is probably not a surprise to anyone. Water heating is a next end use of that warrants focus in an electrification strategy. Water heating accounts for almost 20% of residential energy consumption in Wisconsin. It's the second largest end use opportunity for home or residential electrification. And heat pump water heaters are a big part of that discussion and the key electrification technology. Again, there are multiple benefits from a heat pump water heater. They're more efficient than gas or electric resistance. They can enhance safety, again, primarily by removing combustion for water heating in the home. And they're controllable, certainly through electrification itself. Emissions are reduced as the grid gets cleaner. And like air source heat pumps, there are cost-effective applications, but again, the incumbent fuel matters. It's hard to compete with cheap natural gas. Heat pump water heaters also had a tax credit that expired at the end of 2020, and Focus also offers incentives on heat pump water heaters. There were just a few projects in 2019, fewer than the air source heat pumps. And of course, those projects are supported by energy savings calculations in the Focus TRM. The graph to the right here is just a simple illustration that shows that while natural gas water heating, this is expressed in emissions, which is the notion that the emissions use through the use of an end use becomes more efficient over time as the grid gets cleaner. So this puts that on a chart so that you can see that heating water with a heat pump water heater is just going to get cleaner over time, whereas a natural gas water heater will maintain the same level of emissions over time. Lastly, cooking is an important consideration in residential electrification, and not so much that it has a lot of energy efficiency or emissions reduction to unlock. It's more the case that it's the holdout. It's likely to be the last appliance or piece of equipment that would be electrified because of human or consumer preference for the gas technology. So when heat and water are electrified and cooking is not, we can imagine a scenario where the fossil fuel infrastructure would be developed or maintained, only to serve cooking, and that's just not viable. So it's important to consider cooking kind of as within the bundle of home electrification when we're thinking about the end uses that can be converted over time. There are multiple benefits. We're primarily talking about induction technology here. I should have mentioned that. There are multiple benefits to that induction technology. Speed to boil. I have one of those small hot plates, and it is the equipment to use for pasta when you're really hungry and need to eat fast. The speed to boil is real. There are indoor air quality benefits, particularly compared to gas cooking. There's a lot of pollutant released in cooking anyway, and particularly in gas cooking. So there's like an indoor health or an indoor air quality benefit that can be imagined from transforming to induction cooking in our kitchens. There's minimal wasted heat, and through, again, the electrification, there's lifetime emission reductions from moving from natural gas to induction electric cooking. Challenges remain with this technology, chiefly being that there's a high incremental cost. This is kind of spendy equipment compared to other options for consumers. The efficiency gains are kind of uncertain. There's been some study, but more study is warranted. It might not be an efficiency winner, probably not a loser either, but probably not an efficiency savings candidate. There are currently no focus incentives or no tax credits available for induction ranges residentially, but we do see a small number of incentives available in jurisdictions where there are clear electrification imperatives. And by that, I mean places where there are gas bans. There are a couple of communities that are offering induction range incentives, either standalone or bundled in new construction, I think is where we see them. Okay, with that, I'm curious to see who in the virtual room of the attendees in our virtual room, what the appetite is for electrifying different devices. So if you would, please go to the Mentee, again, www.mentee.com, and enter the code 727831. EVs are winning. And I didn't talk about clothes dryers. It's in this list of what might be electrified. I know there's a national lab working on an ultrasonic dryer, probably not for a residential application anytime soon. But that seems like a completely game-changing piece of home equipment. It's not commercialized yet or ready to buy. But I'm particularly excited about that one. EVs are the winner here. 40 saying that will be their next next piece of equipment to electrify. Great. I should have added snow blowers on here. The options for electric snow blowing are also becoming increasingly affordable and quality and available. Great. So again, in the spirit of the mosaic, and with the idea that a lot of interventions can be or are best stacked to achieve our clean energy and climate goals, I want to just quickly do an overview of how demand response, storage, and even microgrids are relevant and important for beneficial electrification. And to be clear, this is no deep dive or intended to offer expertise in any of those three areas. It's purely an overview to illustrate that these are connected issues when we're thinking about combining a whole portfolio of interventions to reduce emissions through electrification. So truly back to basics, demand response is a way to balance supply and demand on the electric grid. Demand response programs can lower the cost of electricity by deferring build and in wholesale markets, and in turn, retail rates, and basically involve consumers reducing or shifting their electricity usage during peak periods. This reduction or the shift of use is typically a response to a price signal, like time of use pricing, critical peak pricing, variable peak pricing, real-time pricing, or other kinds of rebates. In the olden days, and they still exist, demand response was probably most recognized as including direct load control programs, where a power provider might cycle your air conditioner or your water heater on and off during periods of peak demand, again, in exchange for a financial incentive. Demand response programs are increasingly valuable for beneficial electrification and grid modernization overall, because it helps optimize flexible demand and other technology and other technology that enables it. Like, for example, sensors can detect grid issues. Advanced metering infrastructure makes it possible to offer customers time-based rates with more ease and efficiency. And smart devices like smart thermostats in our homes make it easier for consumers to see information and learn about their own patterns, and in relatively real time change their behavior to reduce consumption, to reduce costs, and even emissions during peak times. This load flexibility graph is borrowed from the Rocky Mountain Institute's Building Electrification study, which is, if you haven't taken a look at it, I'd recommend doing so. I just think that this graph all on its own gives a really good look at different load profiles. In here, we see water heating, air conditioning, clothes drying, EVs, when they're controlled, as they're shown on the top there, and when they're not. is when they're uncontrolled is shown on the top and controlled is shown on the bottom. So we want to look at the yellow line to see what can be accomplished by seizing the opportunity to manage that load flexibility potential. This is really important because cost varies by time of day, emissions vary by time of day or can vary by time of day, and there's just a lot of flexibility potential to think of as a grid asset, I would suggest, because end uses don't all require energy draw and use at the same time. EV charging can be managed so that it's using the cleanest resources at a time when it's not disrupting the driver, and water heaters can be heated at an entirely different time than when your dishwasher is running or when you're taking a shower. I always try to rhyme there and say that you can heat your water hours before showers. In the same framing of beneficial electrification and the mosaic of related technology, storage also plays an important role. Storage is basically, again, 101, basically capturing energy produced at one time and then using it at another time. We hear a lot about batteries, of course, but there are other types of storage too, including pumped hydro, which is actually the most energy storage in the US, compressed air, flywheels, and thermal energy storage. Energy storage can provide economic reliability and environmental benefits. It can help the grid operate more efficiently and manage peak demand. And importantly, it enables more renewable resources on the grid because it helps manage the intermittency of things like solar and wind. The sun's not always shining and the wind's not always blowing, of course, but battery storage can capture it when it does and dispatch it for use later. The Department of Energy, I could probably get a lot of different definitions of a microgrid. If you ask a lot of people, a microgrid can be a lot of different things, and I don't claim to be an expert on them, but they do come up in discussions of beneficial electrification in the sense that they have this whole set of interventions can help make other interventions possible toward goals of clean energy and climate. So the Department of Energy describes microgrids as a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries that act as a single controllable entity with respect to the grid. A microgrid can connect and disconnect from the grid to enable it to operate in both grid connected or an island mode. Their relevance in a broader electrification consideration is their local nature, and that they can serve other electrification conditions as EVs come into when EV adoption is place-based. A microgrid can be a solution there. They provide resiliency and backup. We have a New York story after a hurricane that really put a lot of light on the power, no pun intended, of microgrids. And they really just help incorporate other clean and enabling technologies like solar and storage. So a lot of these things kind of pair together or stack to enable, like a mutually enabling relationship. Got one last Mentee here. If you could go to the Mentee site, the code is here, 727831, and give an indication, if you would, about your interest or willingness or likelihood to participate in a demand response or a time of use program. was saying this is a little bit of a surprise. We probably don't have any kind of scientific sample here, of course, but I would have expected the very likelies to not win. But this is this is telling, and I think as the options increase, as the elegance or the modernity of rate design and demand response programs just continues to enhance consumers, residential and business alike, will be able to adapt those and see how they fit their own consumption and achieve all kinds of shared goals, right? I mean, cost reduction, emission reduction, um, and planning ease or grid management ease. This is great. Thank you. So that's really the all of the prepared remarks or points that I had. So in summary, what I was hoping to convey here is that in a 101 way, that electrification of end uses, particularly including but not excluding others, not limited to vehicles, residential space heating, residential water heating, and residential cooking, benefits and promotes from generation on the electric grid, or renewable generation on the electric grid, and things like demand response, storage, and microgrids are really complementary to those interventions. And when they're married with end use electrifications, they can help amplify our progress toward clean energy, and our climate goals. I think Renew is going to moderate and moderate the questions if we have them.
Yep. Hi, Robin. And hi, everybody. I'm Lauren. Thank you for this talk. We have so many great questions that have been rolling in all talk. And I'll start with this one from Tristan. So many people in this state, especially in urban areas, rent instead of owning their own home. What technologies can renters convert to easily and help to contribute to electrification and reduction of pollutants?
It's a great split incentive question that's always persisted, right? Supporting, using influence with landlords. The options are really limited. I think it rests in program design and what those interventions are and the options. I hope I'm not overlooking something as I respond here. The options for that occupant, a renting occupant, they become pretty minimal. I have a friend who has become more involved in their condo association in the pursuit of charging for electric vehicles. And then in Madison, just recently, there's been an electric vehicle charging, ordinance advancement. So I think we'll continue to see that roll out. But in a lot of multifamily buildings, the main equipment, the heating equipment might not even be unit specific. It's probably central. So the options for the occupant are unfortunately limited. And I think using influence in ways other than purchasing equipment directly might be the best avenue.
Awesome. Thank you for that. The next question, we have a few people kind of talking about how they're interested in is, how easy or difficult is ASHP for retrofitting homes? Can it easily replace furnace and ACs in older homes?
Yeah, I'll give a really honest answer there. So the market is maturing, and we need an entire supply chain, or the entire market needs to be supportive of this. So that is from the availability of the equipment that does a really efficient job and is quality equipment kind of on the manufacturer end. We have that midstream role of installers and contractors, or maybe even distributors before that, to be familiar with the equipment and to be advocates for the equipment, to have installation practices be top, that they're fluent and top notch, and they're doing quality installation. So either individually or through interventions including the work that we do here, like this, or whether that be a policy intervention, making sure that all those parts of the supply chain are involved. From a consumer perspective, this is mostly, I can't speak to what it's to like a weekend warrior kind of installation. That's just not, I would not put in an air source heat pump on a weekend by myself. You know, I typically think of a contractor doing that work. And at this stage, there might not be a lot in cold climates. There might not be a lot of contractors super eager to sell that equipment to you. So you might need to be a really informed customer going into that call. And in Wisconsin, it's probably going to lean toward a natural gas furnace sale in any kind of area where there's natural gas infrastructure, but we anticipate that evolving. As far as the equipment role in a home, it's the installation isn't more difficult than other heating equipment installations. It does typically, you're bringing AC, kind of all air conditioning along with the heating in that equipment replacement, but it doesn't dramatically change the complication of the installation. It's got to be charged.
Thank you for that answer.
I would add to that too, because it is both pieces of equipment, if you don't have you do the right math. If you don't have an air conditioner and you're acquiring cooling through the addition of an air source heat pump, remind yourself that you're getting both functionalities. It's not just that much more expensive than a furnace.
Thank you. All right, we have time for one more question, and this has been upvoted quite a bit, so we'll ask this one. Thomas Eggert said that they were talking to an installer, but they could not find one that was comfortable guaranteeing that even the most efficient heat pump would be sufficient to keep their house warm on the coldest day in northern Wisconsin, which can get real cold. They were told that they needed to pick a backup heating source, such as a traditional gas furnace or electric baseboard, which is a deal killer for them and will be a deal killer for many. Do you have any ideas on when you think heat pump technology will be sophisticated enough to provide heating as a sole source?
That's a great question. It is the issue, Tom. You're absolutely right, and it's exactly what we would expect you to have heard. Right now, we would expect to see the installation of an air source heat pump be more cost effective in a full solution when it's your central air conditioning that failed and you already have probably a natural gas furnace as a backup, and then you could use the heat pump for heat all the way through the shoulder seasons for heating and into much colder time. There's this question about the very coldest days and polar vortex, the polar vortex and that kind of thing, and that's not solved with comfort at this time. I think we sometimes lose sight of the power of the really old-fashioned stuff like insulation and air sealing and that kind of the thermal storage attributes that we can use in our homes that help get more out of the heating equipment. So that's one way to overcome or add more potency, I guess, to that heat pump in a really cold time. I'm not sure I have a guess for when the equipment is going to be ready for the market to say that we're comfortable heating with it all through the very coldest days imaginable. But it's worth watching, in a minute by minute way, because the technology has just advanced so quickly, and there are so many manufacturers working heartily on new new advancements and trying to make them more cost effective. So I would say I don't know when, but I'd say stay tuned and that we're really close.
Well, thank you, Robin, for your thoughtful answers, and thank you for this 101 session. Thanks to all of our attendees for coming, and of course, our sponsors, It's 12:45, so we're going to call it, and then we will see everyone in 15 minutes for our next breakout sessions. Thank you.
Thank you.